given that B has occurred. That's the number of outcomes that are in A and B divided by the number of outcomes in B. In this definition, something has happened or something is known, and that is B. We are asking what's the likelihood of A given that B has occurred.
For example, the Titanic mortality. Pick a passenger at random. What's the probability of picking A? Question 1. Survivor, given that the passenger was a man. Question 2. Survivor, given that the passenger was a woman.
Here's the table. So for the first question, if we look at the survivor row with the men column, we can deduce that 332 men survived the Titanic. However, there was 1,692 men aboard the Titanic. So 332 divided by 692 determines the probability of surviving given that you were a man. Look at the survivor row, and now the women column. There were 318 women who survived the Titanic, out of 422 women who were aboard the Titanic. So we take the 318 divided by the 422, we're going to determine the probability of surviving given that you were a woman.
Conditional probabilities. Consider the Titanic mortality table. The probability that you survived, given that you were a man aboard the Titanic, is found by, first of all, determining the total number of men, which was 1,692. And of these 1,692 men, how many survived? And the answer is 332. So numerically, determining this conditional probability value, we find that approximating this number to the nearest thousandths, the digit in the 6 is in the thousandths position. The digit to the right is a 2. So the answer is 0.196. This means approximately 20% of the men survived. We determine the probability that you survived, given that you're a woman. We need to determine the total number of women who were aboard the Titanic, which is 422. And of these women, how many survived? 318. Numerically, the answer is what we see here. The 3 is in the thousandths position, so the 5 says add 1 to the 3, and the answer is 0.754. Which means approximately 75% of the women survived. Consider this mortality table. In this table, you have men and women who have died. Some have died of cancer, some have died of a heart attack, and some have died of other inflictions. If If you select a person at random, what's the probability that the person, question 1, died of cancer, given that the person was a man? Question 2, died of cancer, given that the person was a woman? And question 3, simply died of cancer, irregardless of the sex.
If we look at the cancer column with the male row, we'll discover that 48 men died of cancer out of 220 men. So 48 divided by 220 will determine the probability of dying of cancer, given that you were a male. If we look at the cancer column and the woman row, we'll discover that 36 women died of cancer out of 150 women. So 36 divided by 150 will answer the question, or the likelihood of dying of cancer, given that you were a woman. And finally, if we don't even consider the sex, there were 84 people who died of cancer out of the 370 people who are represented here. So 84 divided by 370 is the likelihood of simply dying of cancer, irregardless of what your sex was.
If we consider simply just a mortality table, and we want to determine conditional probabilities, we want to determine the likelihood of dying of cancer, given that we consider your sex, whether you're a man or a woman. So for the first question, probability you die of cancer, given that you're a man, is found by determining the total number of men in this table, which was 220 men, and of the 220 men, 48 died of cancer. Numerically, we get this value, and the 8 is in the thousandths position. The digit to the right is a 1, so the answer is 0.218. So approximately 22% of the men died of cancer. Compared with the probability of dying with cancer, given that you're a woman, we notice that there are 150 women, of which 36 died of cancer. The answer is 0.24. Notice that this means that 24% of the women died of cancer, so that you are more likely to die of cancer given that you're a woman than that you